Right. So welcome back to algebra. So let's just do a little review. So converting words to numbers. So there's 4 steps. So if you ever get asked a question of what are the 4 steps to converting a word to numbers, this is it. We start at the left. So we write the number in each period. So a period is going to be like thousands, millions. But we follow by the name of the period. We do this for each period. And just remember, we do not include the word and, like 30 and 4, 130. We don't, we omit that. So just a quick little review. If you ever run into a question asking you what the 4 steps to convert words to numbers are, just found it. So let's do a review because it was asked that we do go over slope again. And I'm glad because slope is a super important concept. So I'm more than happy to go over this with you. So slope describes the direction of a line and the intensity or angle that it moves at. And so we're going to calculate that. And so what I'm going to do, this is the slope formula. When you're working through problems, for now, I want you to go through these steps of solving it just to get the habit built in, and then once you get the habit, then you can go ahead and move a little more quickly. But take your time for now. Now, we went over how to assign like x1, y1, p2, or x2 point y2. And I would do that as a step, like literally write that down so you're not making a mistake putting that in. And with that, so our formula is y squared minus y1 over x2 minus x1. And if I said y squared, it's y2. And this is why we write things down, because it can get confusing. Even though you've done it a million times, it can still be confusing. And so what you'll do is you'll go ahead and take your y2 point. Well, this is my y2. I'll plug it in there, minus, take my y1. Take my x2, put it in there, minus x1. Now at this point, stop trying to solve for slope. Just replace the values. You know, the next step we'll solve for slope. We'll start subtracting. But at this point, just set the formula up. Okay, you don't have to do everything all at once. I prefer if you don't do anything all at once. Take your time to move through it to make sure that it's correct. It seems counterintuitive to move more slowly, but the more slowly we work through something, the less chance of a mistake happening, which means we don't have to spend more time correcting. So it's actually quicker to do things slowly. And again, I understand that feels odd. So here's an example. -3, 6 is our point, and 5, 2 is our other point. So we would go in and go ahead and mark this one x1, x2, y1, y2. And then our formula says we take y2 minus y1. So if -2 minus 6, it's going to go ahead and give us 8. And then we're going to take -5 minus -3. And actually, sorry, my bad, -2. Going to give us -8. And then this one's going to be -8 on the bottom. And I made an error on the first part because it's 2 minus 6, which is -4. This wasn't a negative. I made it a negative. So then we can reduce -4 and 8. So normally we would just leave our slope in the fraction form, so we don't have to worry about doing the division. But we can reduce -4 and 8 because 4 goes evenly into both. So 4 goes into -4, -1 times, and 4 goes into 8 twice. So our slope is -1/2. We just leave it in that form. We don't convert it to anything. Our slope is -1/2. And remember, our negative goes down when we're reading left to right. So that's a negative slope, and it's moving it. For every -1 rise, it's moving over 2 run. So we use the letter M to represent slope. I don't know why, we just do. So when you see M, like in our linear equation, y equals mx plus b, M just means slope. If we know the slope, we just replace M with the slope and continue on with whatever math we're moving on with. So let's take a look at another one. So in this case, we are taking a look at, let's figure out which point we're doing this. So it looks like we're taking a look at -2,5 over here. And then it looks like we're taking a look at 3,9 over here. So we're going to mark our x1. And it looks like that's 3. We're going to make this our x2, y1, y2. So then we're just going to start replacing, move them on over. So we want y1 or y2, which is -2, minus y1, which is 9, x2, which is 5, minus x1, which is 3. Okay, remember, we're just setting up at this point. We aren't doing any math. Now that it's set up, now we do the math. So what is -2 minus 9? That's -11. 5 minus 3, that's 2. We're going to leave it this way. Our slope is -11/2. Remember, negative is going this way. Pretty steep. But -11/2 is our answer. We're just going to leave it like that. That's our slope. M equals -11/2. Now, there's going to be some times when we do go ahead and we do our slope formula and we do the calculations where the slope is something called undefined. And undefined is going to be a strictly vertical up and down line. We call that undefined. And that's going to happen when you do your slope formula and you end up with a 0 on the bottom. You end up with the 0 on the bottom, your line is undefined, and it's a straight up and down line. Now, to go with that is we have something called slope equaling 0. And when slope equals 0, it is a horizontal line, so left, right. And that's going to occur anytime that when you work your slope formula, that you have 0 on the top of the fraction. So if you have 0 on the top of the fraction, no matter what's on the bottom, your slope is going to go left, right. It's going to be a horizontal line. So just a reminder, slope of a vertical line is called undefined, and the slope of a horizontal line is 0. So which one of these have a negative slope? And we talked about this. So this one's going to be undefined, straight up and down. This one has a slope of 0, straight left, right and left. Remember, we kind of read the page left to right. So this one's going down left to right. That's going to be negative slope. This green one is going up left to right. That's going to be positive slope. So parallel lines. So parallel lines are two lines which are straight with each other. Let's see here. Can I draw? I can draw. So typically, it's going to be something look like an 11, right? So that's going to be our parallel line. Now, parallel lines have the same slope. So if you ever get a question that says, hey, there's two parallel lines, one has a slope of 1/2, what's the slope of the other? Well, since parallel lines have the same slope, that means the other one's going to have a slope of 11 or 1/2. Okay, so parallel lines have the same slope. So they want to know if this is a parallel line. So let's work through this. We have two lines, each one with 2 points. And so let's see what we can find out. So remember, we start off with our formula, which is going to be m equals y2 minus y1 over x2 minus x1. Now we're not going to think about anything. This is just solving for the first line. We're not thinking about anything. We're not trying to solve. We're just trying to put things in place. So this is going to be my x1. That's going to be my x2 or my y1. This is going to be my x2. This is going to be my y2. So y2, 5 minus y1, 1. And then x2, 4 minus 2. All right, so then 5 minus 1 is going to be 4. Minus makes a positive. So 4 plus 2 is 6. Now we can reduce this because these are even numbers, and we know that even numbers can be reduced by 2. 2 goes into 4 2 times. 2 goes into 6 3 times. So our slope is 2/3. Now for these two lines to be parallel, line 2 has to have a slope of 2/3. So let's try that out. We're just going to set this up. So y2, which is -2, minus y1 over x2, which is 0, minus x1. So -2 minus 0 is going to be -2. And then 0 minus 3 is going to be -3. Now, since I have a negative on the top and the bottom, that actually turns into a positive. So my slope is 2/3. The first line slope is 2/3. So the lines have the same slope, which means the slopes are the same, making them positive or making them parallel. We have parallel lines based on everything we just solved through. So that works. I'm trying to figure out the easiest way to get rid of everything. How do I clear the board? No, yes. All right. So I would give, so we worked through, we found that both were the same slope. And if we have the same slope, they are parallel. So what about perpendicular? Well, what's a perpendicular line? A perpendicular line are two lines that intersect and create a right angle. And you're like, what? So that's okay. Perpendicular lines look something like that. And they could be at an angle, so they don't have to be perfect, because that's definitely not. But you get the idea. And there's a particular rule with perpendicular lines that we follow with slope. And so here you can see some perpendicular lines, like this one is perpendicular. See how it crosses there. This would be perpendicular there. So just creating those like perfect angles at 90 degrees, that would be a perpendicular line. So with perpendicular lines, we call like two perpendicular lines, we're going to have the slope that's a negative reciprocal. What a negative reciprocal is if, let's just say I have one line that has a slope of 3. Right? So we're going to want to convert that to a fraction. Okay? And we can make any number fraction by putting it over 1, and it's still itself. So 3 over 1. So a negative reciprocal, I describe it as negative and flip. So let's do the first step. Let's make it negative. Negative 3 over 1. And then flip it. So that means put the bottom number on top and the top number on the bottom. So the slope of a perpendicular line to a line with a slope of 3 is going to be a slope of negative 1/3, because we went ahead and we made it negative, and then we flipped it. Now keep in mind, if you're starting with the slope that's negative, when you make that negative, going to make it positive. So you do have to pay attention to that. We still flip it, put the top number on top, the bottom number on the bottom, or the top number on the bottom. So let's take a look at another example. So in this question, they want to know if the line is parallel. The slopes of each line are the same. Perpendicular means one slope is going to be the negative reciprocal of the other, or neither. Just have different slopes. All right. So let's see here. We're going to start with our formula. And M, ooh, it's drawing lines. We don't want that. M equals y2 minus y1 over x2 minus x1. All right, so let's just start plugging in values. We have one line, so we're going to start off with 7 minus 9. Here's our y1, y2, y1. And then we're going to put our x2, which is 3, minus 5. What do we get? Now the negative becomes a positive, so we have 7 plus 9, so we're going to end up with 16. That looks like a p. And 3 minus 5, which is -2. Now they're both even numbers, which means they'll reduce. So we have 8 divided by -1, which equals -8. All right, so that's for our first line. Then we're going to solve the slope for the second line and see if they're parallel, perpendicular, or neither. So we're going to do y2 minus y1, which is 2, over x2 minus x1, which is 0. And so 3 minus 2 is 1. And then 8 minus 0 is 1/8. So they're perpendicular because negative. So remember I said if it starts with a negative, negative is positive. This one is positive, and it's flipped. Where this is 8 over 1, we flipped it to 1 over 8. So these lines are perpendicular. Ooh, look at that. That's probably a lot easier way to do it. So those are two perpendicular lines. So we're going to move on to another topic. And in review, I went over this in a very quickly in a previous video, and this is with linear inequalities. This one's a bit of a, as I like to call it, a monster. So I'm going to hold off on this one again. We'll go ahead and do this in a future class because I want to run through this with you. Because this one's a bit of work and uses several techniques, and I want you there so you can ask questions and give feedback on how to solve this. But with that said, we are moving into our linear equations, and we did cover this briefly in another video. And so kind of going over this whole three parts of when we have that in a linear equation. And so just like an equation or a linear inequality, we can do whatever we want to each of these portions. It's just that when we do it to one portion, we have to do it to the others. And so you can see here, we want to isolate the x again, just like in an equation or an inequality. And so the opposite of -2 is going to be 2. So we're going to add 2, but we're going to add 2 to each section. So 3 becomes 3 plus 2, which is 5. Negative 2 plus 2 are 0, so it just leaves us with the x, which is exactly what we wanted. And 7 plus 2 is 9. So now we have the statement that 5 is less than or greater than x, which is less than or greater than 9. And so if we think about that, that's any number on the number line less than. So x is somewhere in between here, because x is greater than 5 or equal to, but less than 9. So it's between 5 and 9, including 5 and 9. And that's essentially what we're doing. So the x represents like we don't know. And the inequality is a range of numbers that we're looking for to solve our solution. Where like an equation tends to have like one solution, but we'll discuss that later too, because there's several situations that involve that. So here's another inequality. Negative 3 is less than or greater than negative 5k plus 1, which is less than or greater than or equal to 6. Sometimes, I mean, we can use any variable we want to represent kind of the mystery number. In this case, we use k. Normally we use x, y, z, but we can use k. That's fine. So remember, we want to isolate k. So we're probably going to start off by subtracting that 1, because subtraction is the opposite of addition. But remember, if we do it to one portion, we're going to do it to all of them. So we're going to subtract 1 from each, and negative 3 minus 1 is negative 4. The negative 1 and the positive 1 cancel out, so we're just left with 5k. Awesome, exactly what we wanted. 6 minus 1 is 5. Awesome, that's what we wanted. Now, we're going to learn a new rule here, and that is because we want to get rid of that negative 5. Now, negative 5k means negative 5 times k. The opposite of multiplication is division. Now, when we're working these inequalities, if we multiply or divide by a negative number, we have to flip our signs. So we flip our signs because we're going to divide each section by negative 5. So we're going to flip the direction of the signs. And then we're going to have negative 4 over negative 5, negatives, negative, negative, positive. So we have 4/5. That's okay. The negative 5 and the negative 5 cancel each other out. Leaves us with k, absolutely what we wanted. And then negative 5 or 5 over negative 5 is negative 1. And it leaves us with the statement 4/5 is greater than or equal to k, and k is greater than or equal to negative 1. All right, so then we can put that on a number line with negative 1 because k is greater than negative 1 and goes all the way up to 4/5. So whatever our k is somewhere in this range. These numbers will make that statement true. All right. So applied problems are just a fancy way of saying word problems. But we're going to learn how to break these down so that you can solve word problems. So the phrases we keep using are less than and greater than. And it's important to know what that means. So when you're looking at a word problem, A is at least B means that A is greater than or equal to B. When you encounter A is no less than B, A is greater than or equal to B. Same thing. A is at most B means that A is less than or equal to B. And when we say A is no more than B, we mean that A is less than or greater or equal to B. So here's a word problem. A rectangle must have an area of at least 15 centimeters square and no more than 60 centimeters square. If the width of the rectangle is 3 centimeters, what is the range of values for the length? We did step 1. We read the problem. I suggest rereading it a second time just to see if you notice anything that goes on in the first time, because you probably read the first time very quickly. So then we assign a variable, and our variable can be anything. In this case, since we're talking about length, let's make the variable L, and L will equal the length of the rectangle. So let's write an inequality using what we learned in the previous slide of what these words mean and how we translate them into symbols. So an area equals width times length. So area 3 times L. In this area, this amount must be at least 15 and no more than 60. Remember those phrasings that we just went over? So we can set up this inequality as 15 is less than or equal to 3 times L, which is less than or equal to 60. All right, so we have it set up. Let's do the math, which is, believe it or not, the easy part. So we have that L in the middle. We want to isolate it. So it's 3L, which means we can divide by 3 because it's the opposite of multiplication. So we're going to divide each section by 3. So 15 divided by 3 is 5. 3 divided by 3 just leaves us with the L, which is exactly what we wanted. And then 60 divided by 3 is 20. Notice we didn't flip the signs because we were dividing by a positive, not a negative. We only flip the signs if we divide by negative. So our statement equals 5 is less than or greater than the length, which is less than or equal to 20. So in order for the rectangle to have an area of at least 15 centimeters square and no more than 60 centimeters square, when the width is 3 centimeters, the length must at least be 5 centimeters and no more than 20 centimeters. You solved it. See? Not that difficult. So we can go back and check. So the great thing about algebra is we can always plug in our answers and make sure they work. And so if you go through and plug in a number there from that range that we said was acceptable, it'll give you a true statement. And that's what we're trying to check. So here's another word problem. You've just purchased a new cell phone. According to the terms of your agreement, you pay a flat fee of $6 per month plus 4 cents per minute for calls. If you want your total bill to be no more than $10 per month for the month, how many minutes can you use? So first of all, there's a really old problem because that's how cell phones used to work like 20 years ago. But it's a very mathy problem, so we'll use it. But yeah, we used to pay about a minute. So let's just work it. So we read the problem, read it again, see if you see anything of interest in there or something that jumps out to you. We assign a variable. So in this case, we're talking about minutes. So the total, we would then write the inequality, and you must pay the total $6, so that's regardless, plus 4 cents per minute. This total must be less than or equal to 10. And so when we set it up, we're actually going to have 6 plus 4 divided over 100, x, because that's our multiplier, which is less than or greater than 10. So sometimes we're not going to do the double on both sides, but we can still get rather complex just using one. We're going to clear the fraction. So what that means is we're going to try to make things a little easier on ourselves. And remember, whatever we do to one side, we can absolutely do to the other. And this is a little simpler version than that bigger problem I want to work out with you. But since I have this 4 over 100, and remember, any number over itself can be turned, or any number over 1 can be turned into a fraction, we're going to multiply by 100 over 1. When we do that, 100 times 6 is going to give us 600. These hundreds are going to cancel out, so this 4 is going to drop down, and now we're not dealing with a fraction anymore. But we still have to multiply it, so 100 times that canceled on, that's a 1, so we're just left with 4x. Now what we do to one side, we have to do to both, so we have the 10 over here, we're going to multiply that by 100, which gives us 1,000. So a little simpler to work with. because we're getting rid of the fraction. Now we still want to isolate that x. So we have this 600. We can get rid of it by subtracting 600, but we have to do that both sides. Now these 600 cancel out, so I'm just left with the 4x, which is exactly what I wanted. And then 1000 minus 600 is 400. So we end up with 4x is less than or greater than 400. I still need to get rid of that 4. Now 4x means 4 times x, so I can undo that with division. So I'm going to divide both sides by 4. The 4's cancel out, leaving me with x. And then 4 goes into 400 100 times. So x is less than or equal to 100. But by all through that, after doing the math, I may have forgotten what I was trying to solve for. And so what that means is if I can use no more than 100 minutes of the cell phone time to have the bill be less than or equal to 10. And I can go back and throw that 100 minutes back into the formula to have it be shown as a true statement. So we're going to sometimes want to graph these lines. So we usually graph a inequality symbol that doesn't have the equals with a dotted line, and we graph the symbols with the equal sign with a solid line when we graph them. So for example, y is greater than or equal to 3x plus 2, I would use a solid line. And for example, with y is greater than 1/4 x minus 5, I would use a dotted line because it's not equal on that one. So we're just going to do a couple more examples here so you can kind of get used to that. And I believe that's an extra slide there. Boom, one last slide we're going to go through. Class just got shorter. So if now when we're in our quadrant, so remember the Cartesian plane that we talk about? If the inequality is y is greater than mx plus b, or y is greater than or equal to mx plus b, it's going to be above the line. If it is y is less than mx plus b, or y is less than or equal to mx plus b, it's going to be below the line. And let's take a look at what exactly we're talking about there. So we're shading the regions, and this is what shading the region looks like. So in the graph, y is greater than or equal to x minus 2, we're going to shade above because this is where the answers are included. If it's less than, we're going to shade below because that's where the answer is included. So greater than above, less than below. All right. So in this case, if we were to graph x is greater than or equal to 3, well, the first thing is we would shade to the right because it's greater than, and that's where all the values greater are. We're going to use a solid line because it includes 3. So solid line and shade to the right because those are the greater numbers. And so let's just take a look at at a couple more inequalities to take some more examples. We're coming to the home stretch. If you need to pause this video, take a break, but we're getting closer to the end. Dun, 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 dun. So if I have negative 3x minus 2y is less than 12, and you're like, whoa, you just added an extra weird lettery thing. Yep, and we can do that. So what we would do in this case, let's say solve for y. That means I want to get y all by itself and everything on the other side. So I can do that. So this, we're going to get that 3x out of there. Now in this case, we have negative 3x. Opposite of negative 3x is positive 3x. The whole 3x with the variable. Before we were trying to just separate the number and the variable. Now we're going to get rid of the whole thing. Now, what I do to one side, I have to do to both. So on this side, negative 3x plus 3x just nullifies itself. We're just going to bring down the negative 2y. 12 plus 3x, we can only combine things that are alike. Since this has the number and the variable, it is not the same as just a number. If you need to go over how to combine like terms, let me know. We will review that. Super important. Since it's like that, we can only state them out. We're not going to do any math to it. So we're going to have 3x plus 12. Now, I want to get rid of that negative 2 with the y. So the opposite of multiplication is division. I'm going to divide everything by negative 2. Negative 2 into negative 2 goes into 1. So I just have y, which is exactly what I wanted. But wait, remember, if we're dividing by negative 2, we flip the sign. So flip the sign. 3x divided by negative 2. We're not even going to worry about that. We're just going to keep it as that. We represent it as negative 3.5x. 12 divided by negative 2 is negative 6. So y is greater than negative 3/2x minus 6. That's a thing. We can leave the x there. We'll get more experience with that as we move along. Probably not in today's examples, but that's a completely legitimate answer. So let's figure out which ones of these are the way to go. And so we'll take a look at that first one. So 2x plus 5y is greater than or equal to negative 10. So we're going to start off with drawing that on there. So 2x plus 5y is greater than or equal to negative 10. So I want to isolate the y. So let's start off by getting rid of that 2x. And so the opposite of 2x is negative 2x. It just gets rid of the 2x. So I'm going to move the 5y down, which is greater than or equal to negative 10. All right, now I want to isolate that y. So that's 5 times y, opposite of multiplication, division. I'm going to divide everything by 5, which negates it there, and it's just y. And then I'm going to negative 10 divided by 5, which is negative 2. I don't flip the sign because there's a negative. I didn't divide by a negative, even though there was a negative involved. Two different things. So then y equal or it's greater than negative 2, which looks off. And guess what? I violated our rule. Whatever I do to one side, I have to do both. And I never subtracted the negative 2x over here. So this should actually be, I should have subtracted 2x over here. Can't really combine them two, so it's just there, but it still would be divided by 5. So it would be negative 2x, negative 2/5 x minus 2, which is this one. So look at that. Caught me in a mistake. I'm okay with that as long as you kind of learn from that. All right, let's take a look at this other one. 3x minus 2y is greater than or equal to 10. You know what? Let's see. Can I change colors? I can. Let's go to a traditional black. That might show up a little bit better. So 3x minus 2y is greater than or equal to 10. All right, let's start off getting rid of that 3x. It's the exact same procedure we've done, except this time I'll try to do it without making a mistake. Those cancels out. That gives me negative 2y. What do I do to one side? I have to do to the other. I have to do what I say. So we're just going to do negative 3x plus 10. We can't combine those because they are not like terms. Let me know if you need to know what that means. So negative 2 times y, we're going to divide by negative 2, which just leaves that with y there. Because we divided by a negative, we're going to flip our sign. We keep that equals. Negative 3x divided by negative 2, negative and negative make a positive. So this is going to be 3 over 2x plus 1 divided by -2 is going to be -1/2. Normally we just put that, instead of having that plus sign, we just put the negative sign, but I had already drawn that, so that's okay. So y equals 3/2. Where did I get the 3/2? Did I switch? We're dividing by 3. Where did I make a mistake? We subtracted by 3. We're dividing by 2. I set that up. 3x minus 2y is greater than or equal to 10. We subtracted 3x from both sides. Got canceled. -2y leaves us with -2y minus 3x. It does not seem right. I don't like any of those choices. Minus 2y. Yeah, we have to divide by -2. So none of those answers. I'm going to stick by my answer that they are incorrect. If you still see my error, let me know. I'd be welcome. But right now I'm thinking I'm correct. Feel free to prove me wrong. And so we'll take a look at this example. Which ordered pair is a solution? So now to test an ordered pair solution, we're just going to plug those in and see if it tells a true statement. So remember that this is our x value. So wherever we see x, we throw that in, and I can make sure my spotlight is on. Wherever we see x, we're going to plug that value in, and wherever we see y, we're going to see what that value, plug that value in, do a little math, and then see if it all works out. So we're going to start off by just plugging in values. So 5 times 0 minus 2 times -3 is greater than or equal to 6. So 5 times 0, 0, we love it. -2 times -3, it's 6. Positive, negative and negative make a positive. Look at that, first try. So this is a true statement because 6 is less than or equal to, that's the important phrase on that one, 6. So we hit it on the first one. 0, -3 is the correct pair to make that solution true. All right, just a couple of more slides here, and then we'll be done for this video. Oh, look, even says at the bottom, I didn't notice that it had the answer on the bottom. Yay. Wish the other one had the answer. That one seemed fishy. Like I said, like feel free to find out that I did do something incorrect. I would love that. So in y is greater than or equal to -3 over 2x plus 1, we graph the boundary of the line. Get my spotlight on. So and then we test a point. And we'll test 0, 0. And we just kind of do what we did, where we replace the x and y points with 0 to test it. Now, if that is not a true statement, means it's not the solution, and it's on the left, 0, 0 would be on the left side of it. That means the right side is correct, and we're going to shade in the correct side. Similarly, y is less than 6, so no equals to, so we're going to use our dotted line. We can test a point. I'm going to test this point here of 0, 0. So with 0 less than 6, that is a true statement. So that means this side is correct. And then we're going to graph 4x minus 2y is less than 7. I'm going to test 0, 0. 4 times 0 is 0. Negative 0. So is 0 less than 7? Yes, it is. And 0, 0 is on this side. I'm going to shade that side in. It is not an equal to, so I'm going to use a dotted line. All right, just wanted to leave you with one more thing. And this is our 4 steps for converting numbers into words. We start at the left. We write the number in the period, followed by the name of the period. We repeat each period and do not include the word and. So this is 1,209. Not and 9. I know we do that a lot. 209. This is a long class. I hope you picked up on that. Feel free to come back to this. Feel free to fix my mistake in that one problem where I'm pretty sure I was correct. I may not be. And I'll see you in class. Have a good one.